students, myself Dilip Udani, Assistant Professor at LJ Institute of Engineering and Technology. Today, in ordinary differential equations of higher order, I will teach you non-homogeneous linear ordinary differential equations of higher order with constant coefficient. And in this topic, I will teach you how to find out Pi when Q of x, that is equals to e raised to ax into v, where v is a function of x, and this is case number 4. So let's start. So we have case number 4. When Q of x, that is equals to e raised to ax into v, where v is a function of x, and as all of you know that Pi is given by this formula, that is 1 over f of d q of x, and this is equals to 1 over f of d q of x is e raised to ax into v. So what we will do, we will just keep e raised to ax outside 1 by f of d, and then after we will replace d by d plus a. So we have f of d plus a, and we will keep this v as it is. Now we will apply 1 over f of d plus a operator on this function of x. How? I will make you understand this concept with the help of examples. So this is example number 1. Solve d square plus 4d plus 4y equals to e raised to minus 2x sine 2x. So this differential equation is of the form function of dy equals to q of x. If we will compare the given differential equation with this one, we will get function of d, that is equals to d square plus 4d plus 4 and q of x, that is equals to e raised to minus 2x sine 2x. And here its solution is given by this formula, that is y equals to cf plus pi. Cf is complementary function, and first of all we will find out cf. How to find out cf? We will write down f of d equals to 0. We will replace d by m. So we have f of m equals to 0. Now in f of d, that is d square plus 4d plus 4, we will replace d by m. So we have m square plus 4m plus 4 equals to 0. Now we will factorize this equation. We will split the middle term 4m, and we will find out two numbers such that their product is 4 and their addition is 4, and those two numbers are 2 2s are 4. So we will keep m square as it is. Then after we will split 4m as 2m plus 2m plus 4 equals to 0. Now taking m common from these two terms, so into bracket we have m plus 2. Then after taking 2 common from these two terms, so into bracket we have m plus 2. Now again taking common m plus 2, we have m plus 2 in one bracket, and in another bracket we have m plus 2, that is equals to 0. So we have m equals to minus 2 or m equals to minus 2. Now we will write down cf. Now for this minus 2 we will write down c1 e raised to minus 2x plus c2. Now for this minus 2, as this is repeated root, so we will write down x, and then after e raised to minus 2x. So this is required complementary function cf. Now we will find out pi, and pi, that is equals to, given by this formula, that is 1 over f of d q of x, and this is equals to 1 over f of d is d square plus 4d plus 4, and q of x is e raised to minus 2x sine 2x. Now as all of you can see that this is a problem of case number 4. Here e raised to minus 2x, so the value of a is minus 2, and this is v, and this is the function of x. But before applying the case number 4, first of all we will write down d square plus 4d plus 4 as d plus 2 the whole square, right? E raised to minus 2x sine 2x. Now what we will do, we will just replace d by d plus a, and you can see that the value of a is minus 2. So we will replace d by d minus 2. So this is equals to 1 over replacing d by d plus a, that is d plus minus 2, so it will become d minus 2, plus 2 will be as it is, and we will keep e raised to minus 2x outside, and here we will write down v, and in this case v is sine 2x. So this is equals to e raised to minus 2x, 1 over minus 2 plus 2 will cancel out, so we have d square sine 2x. Now whenever you have been given sine of ax plus b or cosine of ax plus b, just remember, right, that is case number 2. What we will do, we will just replace d square by minus a square. Here the value of a is 2 and 2 square is 4, so minus a square is minus 4. So what we will do, we will just write down e raised to minus 2x. Now applying case number 2, replacing d square by minus 4 sine 2x. So this is required pi. So this is equals to minus 1 over 4 e raised to minus 2x sine 2x. Now the general solution is y equals to cf plus pi, and cf is c1 e raised to minus 2x plus c2x e raised to minus 2x, and pi is minus 1 upon 4 e raised to minus 2x sine 2x. So this is the required general solution. Now we will see example number 2. Example number 2 is solve d square minus 2d minus 1y equals to e raised to x cos x. Now first of all we will compare the given differential equation with the standard form f of dy equals to q of x. Here f of d, that is equals to d square minus 2d minus 1, and q of x is e raised to 1x cos 1x, and its general solution is given by this formula, that is y equals to cf plus pi. So first of all we will find out cf, that is complementary function, and for cf we will write down f of d equals to 0, and f of d we will replace d by m, so we have f of m equals to 0. Now replacing d by m, so we have m square minus 2m minus 1, that is equals to 0. Now we have to factorize this equation. We cannot directly factorize this equation by splitting the middle term, so we will apply the concept of delta method. So we have m equals to minus b plus minus square root of b square minus 4ac upon 2a. So this is equals to, you can see that the value of b is minus 2, so we have minus minus plus 2, then after plus minus b square minus 2 square is 4, then after minus 4 value of a is 1 and value of c is minus 1. So 4 into 1 into minus 1, that is minus 4, and minus minus plus, so we have plus 4, and minus 2 square is 4, so 4 plus 4, that is 8, so we have square root of 8 and divided by 2a, value of a is 1. Now what is root 8? That is 2 root 2. So we have 2 plus minus 2 root 2 divided by 2. Now dividing the numerator by 2, so we have 1 plus minus root 2. So the value of m is 1 plus root 2 and m equals to 1 minus root 2. Now we will write down CF, that is C1 e raised to 1 plus root 2x, then after plus C2 e raised to 1 minus root 2x. Now we will find out Pi, and Pi equals to 1 upon f of d q of x. 1 upon f of d is d square minus 2d minus 1, d square minus 2d minus 1, and q of x is e raised to 1x cos 1x. So we will keep e raised to 1x outside, 1 over replacing d by d plus 1. So we have d plus 1 the whole square minus 2 replacing d by d plus 1. This minus 1 will be as it is, and we will be having v, that is cosine of 1x. Now we will simplify the result. 1 upon applying the formula of a plus b the whole square on d plus 1 the whole square. So we have d square plus 2d plus 1 multiplying d plus 1 by minus 2. So we have minus 2d minus 2 minus 1, and cos 1x will be as it is. Now we will simplify this result. See, plus 2d and minus 2d will cancel out, plus 1 and minus 1 will cancel out. So we have only d square minus 2. So we have e raised to 1x 1 upon d square minus 2 cos 1x. Now on this function we will apply case number 2. And what is case number 2? Whenever q of x is sine of ax plus b or cosine of ax plus b, we will replace d square by minus a square. And the value of a is 1. So we will replace d square by minus 1. So this is equals to e raised to 1x 1 over replacing d square by minus 1, and this minus 2 will be as it is, cosine of 1x will be as it is. So we have e raised to 1x into 1 over minus 3 cos 1x. So this is equals to minus 1 over 3 e raised to 1x cos 1x. So at last we will write down general solution, and general solution is given by y equals to CF plus PI. CF is C1 e raised to 1 plus root 2x plus C2 e raised to 1 minus root 2x, and Pi is minus 1 upon 3 e raised to 1x cos 1x. So this was all about example number 2. Now we will see example number 3. Solve d square plus 2d plus 1y equals to e raised to minus 1x over x square. So first of all, this differential equation is of the form function of dy equals to q of x. If we will compare the given differential equation with this standard form, we have function of d, that is d square plus 2d plus 1, and q of x is e raised to minus 1x upon x square, and the general solution is given by y equals to CF plus PI. So first of all we will find out CF, that is complementary function, and for CF we will write down f of d equals to 0. We replace d by m, so we have f of m equals to 0. Now in function of d, that is d square plus 2d plus 1, we will replace d by m, so we have m square plus 2m plus 1 equals to 0. Now we will split the middle term 2m. We will find out two terms such that whose product is 1 and whose addition is 2, and definitely those two terms are 1 1 ja 1 and 1 plus 1 is 2. So we will write down m square as it is. We will write down plus 2m as plus 1m plus 1m plus 1 will be as it is, and that is equals to 0. Now taking common m, so into bracket we have m plus 1. Now taking one common from these two terms, so into bracket we have m plus 1, that is equals to 0. Now again taking common m plus 1 from these two terms, so we have m plus 1 in one bracket and m plus 1 in another bracket, that is equals to 0. So by equating m plus 1 to 0, we have m equals to minus 1 or m equals to minus 1. So CF, that is equals to C1 e raised to minus 1x plus C2, as this minus 1 is repeated 1, so we will write down x e raised to minus 1x. Now we will find out Pi. Pi, that is equals to 1 upon f of d q of x. So this is equals to 1 upon f of d is d square plus 2d plus 1, and q of x is e raised to minus x upon x square. Now this is equals to 1 upon, we will write down d square plus 2d plus 1 as d plus 1 the whole square e raised to minus 1x into 1 upon x square. Now you can see that this is the concept of case number 4, where the value of a is minus 1. So we will replace d by d plus a, and the value of a is minus 1. So indirectly we are going to replace d by d minus 1. So this is equals to 1 over replacing d by d minus 1, and we have plus 1 the whole square, and then after we will write down e raised to minus 1x outside, and 1 upon x square. We will write down 1 upon x square as x raised to minus 2. Now this minus 1 plus 1 will cancel out, and we have e raised to minus 1x 1 upon d square x raised to minus 2. E raised to minus 1x will be as it is, and 1 upon d square, that is nothing but double integration of x raised to minus 2. So first of all we will integrate x raised to minus 2. We will keep 1 upon d as it is, and then after we will integrate x raised to minus 2, and integration of x raised to minus 2, that is x raised to minus 1 upon minus 1, according to the formula integration x raised to n dx, that is x raised to n plus 1 over n plus 1. So this is equals to e raised to minus 1x, and this is a minus 1, so we will keep minus sign outside, and x raised to minus 1, that is nothing but 1 upon x, and integration of 1 upon x, that is nothing but log x. So this is required Pi. At last we will write down general solution, that is y equals to Cf plus Pi. Cf is C1 e raised to minus 1x plus C2 x e raised to minus 1x, and Pi is minus e raised to minus 1x log x. So in this lecture we have seen how to find out Pi when q of x is e raised to ax into b, where b is a function of x, and we have gone through 3 examples based on this topic. Thank you for watching this video.